Okay, let's take an example here. And let's say you went to your friend's house and she offered you a bunch of cupcakes, and you took this cupcake and you really liked it, and you were like, you know what, can you give me the recipe? And she was like, no, I won't give you the recipe. So what you did, that you took a bite of this cupcake and you started to analyze the recipe in your head, and this is how the recipe in your head was looked like. Okay, now because you've been eating and taking bite from this cupcake more and more, so the recipe was a little bit changing. Let's say instead of 10 gram of flour, it became 15, or it became 20. So in order for you to know that you're actually going to make an exact the same cupcake that your friend made it, you took another cupcake from her house and you took it to your home. Okay, this is the original cupcake, the one that you would like to make at home. And in your brain you started writing the recipe and the ingredient. You know that it's going to be milk, but you don't know how many milliliter or liter is going to be, and so on. What you did when you took a bite, your algorithm in your brain started to find the patterns, and the patterns was this recipe. Okay, and then when you made this pattern, your brain was the algorithm who was finding the rules or the recipe. Here the rules are recipes. Okay, and after you made the recipe, the first cupcake you made from this recipe was this one, so we'll call it model 1. And you took bite from the model 1 and you were like, you know what, it tastes almost 91% as the final one. And so you took another bite from this one, because this one you already ate it at her home. You took this one from her home in order for you to match it with this one, the one that you're going to make it at home. This was made at home after your brain made the recipe in your head. So the recipe was the algorithm, the rules, and the model was the first cupcake you made. Let's say you made a lot of cupcakes. At the end, you were able to make something similar to the first one, which was, let's say, 95%. Maybe the secret was in the toppings or whatever. So this is the difference between algorithm and model. Okay, the training data was that you kept taking bites from the original one. The more bite you took, the more your brain started to find the correct patterns. Okay, maybe there was something here, maybe there was something, let's say a cream here inside, and if you only took a bite here, you won't get to this area. The moment you took more bite and you reached the center area where you had to add, let's say, more butter. So the more bite you took, the more your brain started to give an accurate recipe in your brain, which is the training data. And the test data obviously was the output. You took a bite from the output, and then you were like, you know what, I still need to do more training. So you started to take more bite from this one. These two are original. This one and this one, these are the original cupcakes. Okay, maybe different in the image, the toppings, but if you can see that it's the same cupcake. Okay, I hope this example cleared things up, or maybe it made it more complicated, I don't know, but this is how it works in real life. I'm pretty sure the diabetic example, let me just go to the diabetic example here. Okay, you have 0, 1, 2, 3, 4, all the way, let's say 10,000. Okay, and then I'm here to predict the outcome 1 or 0. Since it's a binary classification, then we're going to use the famous logistic regression, logistic, because there is something called linear regression. So the classifier is logistic regression. Okay, this is the algorithms. We already chose the algorithm because we know that the logistic regression is used for binary classification. Here we have 10,000. I'm not going to take the entire 10,000. I'm going to take, let's say, 8,000 for training and the 2,000 remaining for testing. And these are called attributes or features. Here are called feature. Okay, and which one that I want this one. I want to know if this guy or this person go to diabetes. 1 means yes, 0 means no. Okay, so according to the terminologies that we have, the feature or the output variable that needs to be predicted, so response variable is the last one, which is 0 and 1, and the training and the predictor variable are the other features, which because of those I will be able to find this one. The training data is the 8,000, the first 8,000, and the testing data is the last 2,000. Maybe I can change it, but for simplicity I'm going to make the training is the first 8,000 and the testing is the last 2,000. And the algorithm that I chose was logistic regression. Why I chose logistic regression? Because logistic regression is known for binary classification. Okay, and the model, after I trained the data, I had a model, and then from that model I applied the test data on the model, and then I know if the accuracy of that model. Hope it was clear now. See you in the next video. Bye bye.